Hey, what's up everyone? Welcome to Chapter 4, Rigging with Set-Driven Keys. This will be a relatively short chapter because there's not quite as much to cover. In this lesson, we will learn how to reference in our rig. For this example, it will be the bike from Chapter 2. We will then draw a curve through an obstacle course and use that as a path that drives our bike's movement. Next, we will use the bike's position along the curve to drive these gate arms so that they open and close as the bike passes through them. We'll also learn how we can use the bike's position on the curve to drive our tire and pedal rotation. Alright, let's begin by opening the path scene in the Chapter 4 Materials folder. Now let's reference your finished bike asset from Chapter 2. To do that, press Ctrl R and navigate to where you have that saved. When animating, you always want to reference in your rigs. It's much easier to maintain rig updates when you do this. It's never a great idea to import a rig, although that is what I did in this example scene. I did that because this gate arm is a very simple rig, and I wanted to make sure it exists in the scene when you open it. Because references are looking for a path on disk, I did not use them to build the scene. The next thing we want to do is draw a curve. To do this, I'm just going to go into Top View and frame our gate arms so I can draw the curve easily to go through them. The next thing we want to do is draw our curve. We go to Create, Curve Tool, CV Curve Tool. I'm just going to make a couple clicks that go through all of these obstacles. There we go. Now we want to rebuild or reparameterize this curve. And you can do that by going to the Modeling menu set. And under curves, there is a rebuild. So let's go to option box. We'll do uniform. We want it to be 0 to 1. And we can up the number of spans, which will just make our curve more dense. And basically what this is doing is we want 0 to be at the start of our curve and 1 to be at the end. This just makes our curve easier to work with. You can actually see what I'm doing here if I go to Display, NURBS, CVs. So these are all the points that we made, and when I hit rebuild, it changes them. And they're nice and evenly distributed, which is what we want. Now we're ready to attach our bike to the path here. Let's go ahead and go into perspective view, and we can also remove the display of CVs here by just going back and doing the same operation. We need to switch our menu set back to rigging, and we can go to Constrain, Motion Path, Attach to Motion Path, and let's click on the options here. This is going to be very similar to what we learned for aim constraints. Difference here is how it attaches and animates along the curve. It actually doesn't matter because we're going to delete the connection for this, but we can just go ahead and use the time slider. And we want our bike, which is facing down Z, as the front axis, and up can be Y, and we'll just set it to the scene world up. All right. Just like constraints, we don't want to constrain directly to our control. So if I pick walk up by pressing the up arrow, I can just go up the hierarchy to my constraint group. If you remember when we added that, I'll just make this a little bit bigger so it's easier to see. So here's our constraint group. We'll go ahead and select the path. Actually, it's a reverse order. So you want for motion paths, you want the driven first. I know it's a little bit confusing. Select your constraint group and then the path and go ahead and hit apply. Because we set the range to time slider here, we have a key for the U value along this path. At frame 1, our value is 0, and at frame 120, our value is 1. And you can see that here on the motion path. Go ahead and close our options. And now if I drag along the time slider, that value changes and our bike moves along the path. Let's go ahead and right click this and say break connections. That will get rid of the keyframe there. Now we have control over this path animation. So we can just middle mouse drag and see the bike move. Let's go ahead and use this value to drive our gate arms. To do this, we'll use set driven keyframes. We'll want to go here and change our menu set again, this time to animation. Go to key, set driven key, and open the set option box here. So here we have some options for driver and driven objects. And what we'll want to do is use this motion path. I just selected it here in the channel box, and we're going to load that as the driver. We're going to want to use the U value as the driving attribute. And what we wanted to drive are these gate arms. So I'll just select the control. We don't want to actually add it to the control. So if I pick walk up, press F in the outliner, you can see I've selected the set driven key group. So let's load this in as our driven. And I can go ahead and select all these and use rotate Z as the driven attribute. Let's go ahead and set our first key. We go key. You see there's a blue channel. This represents a set driven key. And we also have an input coming from motion path. When you click on something in this menu, it will select it. So let's select our motion path. And we'll go ahead and change the value now to 0.1. So now, if I go click on these and set a value here of 90, so we use -90, go ahead and set another key. So at a value of 0.1 on U, our rotate Z will become 90. So let's go back to our motion path. We'll set another key at 0.2. Go ahead and key that. We want it to remain up for a little while. And now we'll go to 0.3. And let's put this down back to 0. Go ahead and say key. So now when I drag along my motion path, I get this. As far as set-driven keys go, that's pretty much it. We can go ahead and close this menu. Now all we'll want to do is offset that animation. With our SDK group selected, if we go ahead and go to Windows, Animation Editor, Graph Editor, we can see the set-driven keys that we just made, and this is where we'll want to offset them. If I animate this along, just middle mouse drag, wait for it to close, then we'll want to offset the second one so it starts to open here. So it's this value. Let's go ahead and have it start opening around there. If I select the second one, which is this arm, I'm going to select all my keys, and we're going to offset it by offsetting the value here by 0.32. So I'll say plus equals 0.32, and that will just shift this key over. So now if I continue along down the path, now this one begins to open, and when that one closes, we'll want to open the other one. So let's say at 0.65, we can open the third arm. So let's select these and say plus equal 0.65. Awesome. Let's see what that looks like. Now when this goes along, that opens. Great. Now if we slide our bike forward or backwards, it doesn't matter. These gate arms will open as the bike slides along the path. Let's go ahead and close this. Set this to 0. Let's take our knowledge of set-driven keys one step further and use them to drive the rotation on our bike's tire as it travels along the path. First, we need to take 2 measurements. We'll need to know our tire's radius and the length of our curve. One simple way to find the length of a curve would be to select the curve, and then here in the mel command line, type arclen, ARCLEN-CH1. Press enter, and now, if I select my curve and go to the attribute editor, we can see this curve info node, and this tells us the length of our curve. Now let's go ahead and measure our tire. To do this, I'll go into my orthographic view and create a measure tool. We'll use the distance tool. Now if I just click 2 places, I will get these locators, and I can just drag this one up to the top of the tire and this one at the base, and I can see it's getting about, our diameter is about 11.8. Now that we know the diameter, we can use that to find our circumference. So if you remember from chapter 1, our circumference is 2 times pi, 3.1415, times the radius, which is half our diameter, so it's at 5.54. And that is 34.8 about. So we want to ask ourselves, if this is basically the length of our tire is 34.8, so how many times along our curve path does this need to rotate? So what is the length of our curve path? I'm just going to clear this out. Make sure you have your number copied if you want to use it easily. Clear. Our curve was 203.75 units about. So now I'm just going to divide that by my tire length. So now I know that our tire can rotate, make 5.85 revolutions before it gets to the end of our curve. So I know that a circle is 360 degrees, so let's convert this into degrees. So if I multiply this by 360, we get 2,107. So this is the rotation value that we need to drive with our 0 to 1 u value on the curve. So I'm just going to copy this and go ahead and close our calculator. We can go ahead and get rid of our measure tools, just hit delete, and let's go back into perspective. Let's go ahead and open back up the set-driven key menu, and we'll want to load in our motion path, which I know is on this control here. So if I go into the channel box, select it, we can go ahead and load driver, use our motion path u value again, and we want it to drive these three controls. So if I select these, and I'll focus in to find the group that I want. We want it to do the set-driven key group. Now for this pedal control, I know that the actual control is driving the chain. So we're gonna go ahead and use the control itself, even though I said not to put set-driven keys directly onto controls. For bonus points, you could go ahead and fix this. And instead of using the controls rotation, you could use one of these groups instead. But for this demo, I'm just gonna use the control. Go ahead and say load driven, not driver. Be careful to not have these as your driver. And then select them all, and it's going to be rotate X that we're driving. So we'll go ahead and set a key because we know our U value, if I select my path, is at 0. So we'll key it there. I have to select, it gave me an error because I didn't have the U value selected. So just select that, go ahead and set key. Now on these controls, we have our key value, and we want to set our driver to 1. So that will go down at the end. And if we go back to our controls, let's put in the rotation value that we calculated, which was 2,107.285. Go ahead and enter that and say key. So now if we look closely and drive our path, our bike along the path, you can see it's pedaling. We'll get in even closer to really see what's going on here. And now the U value is driving our rotation. One last thing I want to point out about motion paths before we go is that you can use it to control your object's twist. So if I wanted to, say, bank my bicycle here, I could just use the twist. And now we wouldn't even need these arms to raise because we're so good at riding bicycles that we can just go under the arm. Awesome. There you go. I hope you enjoyed this lesson. Thanks for joining me, and I'll see you in the next one.